This meeting is being recorded.
Okay, so today we're going to talk about trunking. Before we talk about the trunking, yesterday, I think there was a question raised on how does a MAC address look like in the real time. So I want to quickly log into the switch and show you guys how does a MAC address look like. So give me 1 second. Can you guys able to see my screen?
Yes.
Yes.
Okay, so this is a terminal. I logged into a jump host. Here I'm logging to one of the device. I'm sorry. Okay, never mind. So I enter the switch name. It can be any switch name. In this case, I'm using a switch name. AS means associate switch. That's just the name that I gave to the switch, right? So here, when I do show MAC address table, so this will give me the MAC addresses and the type of the MAC address and what port it's learning from. So for example, if you see this line, this is on VLAN number. So the VLAN number is 34. This is the MAC address. It learned dynamically from the port. I mean, someone ping it or someone sent the data. So it learned that from the port channel 1. I mean, that is one of the bundle of ports. Let's look into this one maybe. So if you look into this VLAN 34, MAC address is this guy. It learned dynamically. It's on port, this port. Gigabit.
What is dynamical and static here? May know that.
Dynamic is when a switch send the packet, the broadcast packet, switch is learning dynamically from the device. When they change the device, the MAC address changes. Because you guys know that the MAC address is vendor defined. It is not defined by us, right? So when someone plugs in their own machine, let's say Rishi plugged in his machine, it will dynamically learn the Rishi MAC address. When Sai Sri plugged in her laptop, it will take the MAC address dynamically of Sai Sri laptop. So it is dynamically learned by the device itself. But when we wanted to make sure we hard code, only one device can connect it. For example, I want to hard code, only Rishi can plug the laptop to the switch port. We don't want any other machine to be plugged in. Then we statically code the MAC address of Rishi on that port so that no one else can use that port. You will learn that in port security topic. Port security is where we will put the MAC address either static or dynamic when we wanted to limit the number of MAC addresses or if we wanted to limit that port to a specific user. Is that clear?
If you don't mind, can you please show in the picture format like yesterday you showed, right? Like a switch and all that picture format.
We can do that. That's okay. Let me complete this. I'll get back to that. So here in this case, we are talking about, let's say, okay, this port. This is VLAN 34. This is the MAC address. It learned by the device that's connected on that port dynamically on this port, right? So I can filter my MAC addresses like this, show MAC address table, and then I can define VLAN. I can define VLAN 34. So it will show me MAC addresses learning on the VLAN 34. Similarly, if I wanted to see something on, let's say, let's look into what are the VLANs that are configured on the switch. When I do show VLAN brief, that will show me all the VLANs that are connected on this switch. So it could be, one is like management, one is facilities, one is data, voice, wireless, guest, security control, CCTVs, workstations. So we separate the VLANs based on the user machine. Like it could be a printer, it could be an access control, it could be a wireless access point, like that, right? So we separate them into different VLANs, like we talked yesterday. Here also we separate them into different VLANs. So that's about that. So coming back to Lakshmi question, before I stop this, do you guys have any questions here on this switch?
Ravi, you said there will be another column of age. Yesterday.
Yes. Yes. The age depends on the model. Some devices show the age, some devices does not show the age. This model, for example, this is, let me see, show version. So this is Cisco 2960 model. So maybe this model is not showing the age of the entry, but some of the devices show, some of the devices does not show. It's not mandatory. Every make and model, just like an iPhone maybe look and feel differently than an Android. So this device may be showing differently than a different device. So it's not, it's like not one shop all for everything. But good catch there. Yeah, sometimes it shows, sometimes it doesn't.
Oh, okay, got it. Yeah, thank you.
Yeah, no problem. Okay. Anything else, guys? Okay, I'm going to stop share of that one. I'm going to go with the whiteboard. So, Lakshmi, so there is a switch. Let's say switch 1. And there is a port. Let's say the port number is 5/2. Just the port number, any port number, right? Here, let's say there is a iPhone. When someone plugs in the iPhone to the switch port, the switch automatically learns the iPhone MAC address. This learning is called dynamic learning. If they take off that iPhone, and let's say I brought my camera, now the switch will replace the iPhone MAC address with the camera MAC address, because it is changing it dynamically. It's not hard-coded MAC entry, it's not static entry. Now let's take a different port. And here on this port, let's say I did MAC address BB, MAC address BB, like that. So I can plug in only BBBB MAC address. I cannot plug in either the camera, or I cannot plug in iPhone, or I cannot plug in any devices. What device I can plug in? Only I can plug in this MAC address device. This could be maybe, let's say, a locker. So to secure this port, we wanted to make sure that only a specific MAC address that we know, they can only connect to this port. Then we will statically configure the MAC address. Clear? Yes, no?
Yes.
Lakshmi?
Yes, Ravi. Yeah. Thank you.
Okay, good. Okay, now let's talk about trunking, guys. Trunking. So what is a trunk, right? Trunk is allowing multiple VLANs on a single link. What does allowing multiple VLANs on a single link really means? All right. So let's say there is there is a switch. Switch A, and there is a let's say this is a server. This server may have two devices in it. These can be called as virtual machines. Do you guys know what is a virtual machine? Can anyone tell me what is a virtual machine? Anyone from the computer background? Virtual machine? No? Yes? Anyone
It's
want? Yeah. Go.
Not a physical,
It's
it's not a physical machine.
Okay, yes, it is not a physical machine. But to go into deeper, let's say there is one big machine. Let's say this machine has 100 GB hard disk, and this machine has maybe 6 CPUs, maybe like 10 gig RAM, right? So this is the components of this machine, but we can separate this machine into two logical components, right? So we can assign the hard disk, CPU, RAM into a logical machine inside of that physical box, which is called virtual machine. We can, for example, this virtual machine can have 50 GB hard disk, 3 CPUs, and 5G RAM. And remaining resources can be assigned to a different machine inside of it. So a logical separation of a physical hardware into 2 or 3 machines is called virtual machine. For example, you can go and buy a Apple laptop. Inside an Apple laptop, I can assign the resources to a Windows machine. So that installation is called building a VM inside a physical machine. So in my Apple MacBook, if I have 100 GB data, I can separate them into 2 different machines because I don't want to buy 2 systems. I don't want to buy Windows again. I can just make my Mac as Windows as well. I don't know if you guys heard this before or not. When you go to a corporate network, they will give you a laptop. Inside that laptop, you can build a different machine because you can separate your work environments like a dev environment or prod environment, or you can separate them like an procurement where you can store your data separately than your local machine, right? They separate in different use cases. So the reason why I brought that here is, let's say this server has virtual machine A and virtual machine B.
You
And
mean to say VPN, like kind of VPN?
No. VPN is you are connecting to your data center from a remote location. For example, you're in US, you wanted to connect to a data center somewhere corporate network, but you are remote to the device. Then you will VPN to your corporate network. That is called virtual private network. So you're creating a tunnel to talk to your own network over the internet. So I'm not talking about the VPN here. I'm talking about building a machine inside of your machine to use your resources efficiently and separate them.
Okay.
As I said, so if you want, let's say you have a MacBook, right? You have a headquarters, corporate headquarters here. You are sitting in a Starbucks coffee shop. Your laptop, you're sitting in a Starbucks coffee shop. You wanted to access something of the headquarters. So then you will build a VPN tunnel to your machine, and over that VPN tunnel, you can access your headquarters. That is one way. They will provide you a URL. You will hit that URL, and then you can access. That is called remote SSL VPN. That's a different way. Some people, they do it as VDI, which is called VMware, virtual desktop image. That is what is, they will give you an image to install on your laptop where you can securely connect to your network. So those are all different ways to connect. We are not talking about that. What we are talking is, you have a machine. Inside of this machine, you wanted to separate them into two logical partitions so that you can use them for different use cases. For example, I am a HR user. I wanted to use one machine for my HR stuff and other machine for my finance stuff. In that case, I can build two different machines in it. Okay, I went too far on the VPN, so let's not worry about the VPN for now. We will maybe cover that. I think it's a CCNA security concept. It's not CCNA route and switch concept, but we will try to cover that maybe a little over the future, but not today. Now let's focus on the VM. So in the server, there is VM A and VM B. But what happened is, this VM A does not need to talk to VM B. So even though they are on the same server, we wanted to separate them. How we can separate them is putting the VM A in VLAN 10 and putting the VM B in VLAN 20. We are separating them in different VLANs, right? But on the switch side, yesterday we discussed about putting an access port, like putting in a VLAN 10 or VLAN 20, correct? Either we can put this port in VLAN 10 or VLAN 20. But how does that going to solve this problem of having two different VMs on a single server? How can we pass both those VLANs? So there comes the trunking. I think I can write that. So trunk, what does this trunk do means? It will allow VLAN 10 and VLAN 20 on the same link. So it will allow VLAN 10 and VLAN 20 on the same link. But because you are seeing these different colors, they will differentiate them. So on this link, it will allow VLAN 20 and also it will allow VLAN 10. But how does it going to separate them? Using the VLAN header concept. So when it's sending the data, for every packet, it will attach either 10 or it will attach VLAN 20. So when the switch sees that, okay, we created it as a trunk port. Now I am seeing the VLAN 10. So I'm going to send that packet to all the ports in the VLAN 10 only, because we saw the VLAN header value of 10. When it comes with VLAN 20, oh, okay, now I saw with VLAN 20 on this port, I'm going to send to ports on VLAN 20. So now this packet goes to, it will be sent to the ports on VLAN 20. So even though you have a single link, to allow multiple VLANs on a single link, we use a concept called trunking. Questions? Okay, let me ask. The whole purpose of separating the customers or departments is a VLAN. Then what's the point of creating the trunks? Can anyone answer? Let me repeat the question. The whole purpose of separating the users is VLAN, right? We are separating the users. We are putting them in different VLANs. Then what's the point of having trunk? Are we really separating them?
Because they are in the same server.
Yes, they are in the same server, but my question is, are we really separating the users? I mean to ask, is this secure? Varun, is it secure?
I guess it is.
How it is secure? We are using a single link to allow both the traffic of VLAN 10 and VLAN 20. Don't you think it is not secure?
But the response is getting segregated, right?
Correct. The response is getting segregated, but on the incoming traffic on
Yeah,
the server,
yes, I had that doubt. Like when switch is sending pack, I had that doubt. I was about to ask, when switch is sending the packet, how could they? The response part was clear, but the request part was, I did not. I had that doubt.
okay. Anyone can tell me, is it secure or not? I mean, Varun said it's secure, but it was return traffic is secure. But what about the outgoing, the inbound traffic, right? So my answer is, let me give you that, right? So my answer is secure because it does a concept called encapsulation. What is encapsulation? Before talking about the encapsulation, let's talk about a capsule. Do you guys know what is capsule?
Yeah.
It's like a small tablet. When you open the
Covered.
tablet, you will see the data in it, right? Like the small crystals. It's like a capsule tablet, the one we take, right? So encapsulation is the same thing where we are separating VLAN 10 and VLAN 20 on the same link using a capsule concept. So let's draw that out. So let's say this is the ones and zeros data. So we are securing them within a capsule with the header value of 10. So no one outside the VLAN 20 can go to the inside because it is encapsulated with VLAN 10. So when the packet comes in from the server, if someone wants to send an intrude into that VM, they cannot because it is encapsulated, it is protected by the header tag. So how it does it is, it will create like a channel. For example, think about like this. So when the server sends the first one, it sees that, okay, it's coming from a VLAN 10 tag. So on the B side, I mean on the VM B side, they have to manually tag with VLAN 20. If they don't tag it, the port will never allow it. Similarly, on the A side, they have to manually tag it with the VLAN 10. If they don't tag it, it will not allow because it already encapsulated with VLAN 10. The switch encapsulated with VLAN 10. So on the trunking, it is very important for the user on their machine to tag with the right VLAN tag. If they don't tag it, you will not receive their MAC address on the switch. So to make that secure, it is the responsibility of the user to tag their traffic with the specific VLAN tag. That is how we can make it secure with the concept of encapsulation. Making sense? Yeah, let's ask. Ritik, how does the trunking is secure?
So if when the switch A sends a request, it basically requests from a particular VLAN port, so VLAN tag. So the both VMs, like they will send, the users will send with the VLAN tag. so that switch can able to accept the data from those that VLAN, that VM. So basically using the encapsulation method, we can able to secure this communication.
Yes, that is correct. So the user responsibility is to tag with the right VLAN, and then switcher responsibility is to send that traffic encapsulated so that no one can read the other user data. So here encapsulation is the technique, and this encapsulation is called, for the book, right? Again, the book name is called 802.1Q encapsulation. This is the technique. This is called industry standard. 802.1 is the IEEE standard for this mechanism. I think 80 means 1980, 2 is called February, I think 1 is called date, something like that. You guys can Google it. That's how it came. How does this .1Q came, right? I think this number is like there is 802.1A, 1A, and next protocol goes with 802.1B. So these are all different protocols, right? For example, if you're writing a paragraph, you do 1.1A, 1.1B, 1.1C in your like index, right? Similarly, they for every protocol they gave one index number, and this index number became Q. That's it. That is how the name came. If you're like someone who is like a geek, you can Google that stuff. But that is not okay. So this is called IEEE standard, right? Cisco has its own standard, which is called ISL, ISL standard. That is also an encapsulation technique, but it is not, what can we say? It depreciated. It's not no longer in use. No company uses ISL. It's like an old technology, same encapsulation, but it is not that secure. Some of the people can hack it. That's why they stopped it. As simple as that. But just for theory, Cisco has its own proprietary ISL. And yeah, that's about that. That's about trunking. Now let's move on to spanning tree. How do I? Okay. So spanning tree. I think yesterday someone asked about having a loop inside the inside the network, right? So let's talk about that. Okay, so there is a PC. The PC is connected to the PC is connected to switch A. So the switch A is connected to switch B, and switch B is connected to switch C, and this one is like the topology is like this. So when the frame comes in on switch A, the packet can go to switch A, switch B, or switch C, right? And the switch B can give that packet to switch C, and switch C can give that packet to switch A. What is the problem here, guys?
The loop between the switch A, B, and C.
Yeah,
The packet is not going to the ultimate destination.
Well, okay. Well, let's say the destination is here. Destination. Yeah. So the packet went to switch B sent to switch C sent to switch D, and also switch A. In this case, the packet went to the destination. Is that a problem?
Any duplicates created.
Broadcasting.
Duplicate packets.
Okay, so someone said looping. So looping creates duplicates, correct? Because it's getting looped, and that creates duplicates. Okay, but what is the problem? What does the duplicate cause the problem?
Too much of traffic overload.
Okay, what will cause the switch? I mean, what does the overload cause to the switch?
Time consuming.
Hang up.
Correct. The switch will go completely down, hang up. The switch will not respond the way it should because there is a limitation for the MAC address table. So because of this looping continues, all the MAC addresses get full again and again. They keep on fluctuating between them. It causes the loop between them, which will cause the, someone said broadcast. It's called broadcast storm because it keeps on broadcasting. It's called storm. And then someone said duplicate. Yes, it causes the duplicate between the packets, but it sees the same MAC address again and again from two different directions. So it's seeing its MAC address going out and going to C, and it's learning the same MAC address coming from C. So there is a duplicate coming from two different ports, right? So this is all causes the switches to go down. So to avoid that, how do we avoid this? Let's talk about that.
By using VLANs?
How can we
By choosing the shortest path and making the other one as the backup for the redundancy.
well, okay, I think let's talk about the first answer. So someone said VLAN. So let's say you put this port in VLAN 10. 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 VLAN 10. VLAN 10. And your destination is in VLAN 10. Destination is in VLAN 10. So if you change one of this port to VLAN 20, if let's say you want to change that to VLAN 20, there is a mismatch of VLANs here. This port will never work. If this port, if this link, I mean, if this mismatch causes the link go down, then what's the point of having this link, right? We want to have this link up and active in case of failures. For example, let's say this link went down. We need to have switch a backup path to go to the switch C and go to the destination. Let's say if this go down, we need to have path of this guy to go to switch B and then go to switch C and then reach the destination. The whole purpose of having two uplink switches is to have redundancy. If you do the VLAN mismatch, it does not going to work because this link will always stay down. Then what's the point of having redundancy here? So having different VLANs is not the right fit. So let's ignore that. Okay, someone told backup link and the shorter path. Can you elaborate on that?
So we have to check the cost of each path, and which is, like the lowest cost. That will be as the like main connection to, for the communication, and the other link would be as a backup.
Okay, what
If
is
one
cost?
goes down, what do I say? To have this. I've learned this earlier in the first introduction when you said we have to go through. I just had one note of this in depth. I don't know the like knowledge in depth.
Okay, got it. Okay, understood. Okay, cool. I know you are referring from somewhere when you said the word cost. I know you're bringing it from somewhere. That's why I asked what is cost. That's okay. So let's talk about that. So there is an destination here. So we need to have a mechanism where these switches will talk between them. These switches should talk between them. They should talk and elect best path between them. So switch B should talk to switch C. Switch C should talk to switch A and elect one of the best path to reach the destination. So what are the two paths here? One is PC1 sending to switch A sending to switch C, and switch C sending to destination. That is one path. What is another path? PC sending to switch A sending to switch B sending to switch C, and switch C sending to destination. So there are two paths, right? But which one is the best path?
PC to switch A to switch C to the destination.
Why?
But both are
It's
same,
the
right?
it is the like shortest with like from switch A to switch C we can go directly. Here we are using the switch B in between and making it like complicated.
Exactly. It's like taking a direct flight instead of taking one of the transit flight, right? You're making one more extra stop before you reach your destination. So let's say you're going to India, you stop in Dubai and then go to Mumbai and then go to your destination again. Or you go to Dubai and then directly go to your hometown. So it's like having one more extra airport in the path. So in this case, going from PC to switch A to switch C, directly going to your destination is better than PC going to switch A, then switch B, then switch C on the destination. So we have a better path here because of the lesser number of hops. We can say that manually, but how does the switches know, right? So switches will do a protocol called BP. Switches will talk between them using a protocol called BPDU. BPDU. It's called Bridge Protocol Data Unit. What does this mean? So switch A and switch B and switch C, they all send a BPDU message between them. What will the BPDU message contains? It contains a value called priority. Priority. Switch A will send, my priority is 55. Switch B will send, my priority is 58. Switch C will send, my priority is 59. So here, whichever switch has the smallest priority, that switch is called root bridge. So in this case, which is root bridge?
Switch A.
Switch A is the root bridge. So what the switch A does is, switch A will put both of its link in the forwarding state. Okay. meaning the packet can go via this way or the packet can go this way. Doesn't matter, right? So next up, 58 versus 59. Which one will be selected first?
Switch B.
Switch B, because this has the next lower priority. So this one will be the next forwarding switch. So the packet goes here and it will elect the port as this one as the forwarding port, and switch C will put the port in the blocking state. So this port will be temporarily blocked. So to reach the destination, what is the path? Switch A sending to switch C and switching C sending to destination. Because the link between the switch B and switch C is temporarily blocked, switch B doesn't know how to go to the destination. Switch A will send that to the switch C and switch C go to the switch D. What if this link go down? When this link go down, switch C and switch A know that this link will went down. Switch A, because of the root bridge, it will send the data to switch B, and switch B will automatically unblock this port and send the data to switch C, and switch C will send that to the destination. So all the switches will elect a root bridge. They all will elect a root bridge based on the priorities. And who define these priorities? We manually define these priorities. In this case, if I am the right engineer, what I'm going to do is I'm going to put the switch A as my 55. I'm going to make my switch C as 58. Because I know going this path is always shorter, I will make sure that switch C will always have the port up, and then I will make this one as 59. So that way we can block this port. The port will always, the traffic will always go via switch C and then goes to the destination instead of making the longer path. Okay, does that make sense? Let's say, for example, okay, let's say the priority of switch B is 50. This priority is 60. This priority is 61. So in this case, what is the root bridge? Switch B is the root bridge. This is the root bridge. So it has to be forwarding this port. It has to be forwarding this port. What is the next root bridge? 60. So it has to forward this port. It has to forward this port. And which port to block? Here in this case, switch C. Which port it's going to block? Either this port or this port. Which port it's going to block?
From B to C.
Why?
Because in switch A, we have both the ports available. So we can go through switch A to switch C.
But my root bridge is 50. This is the first priority. Then switch A.
Okay, okay. Then from switch A to switch C will be blocked.
So the thing is, switch B is the root bridge. So it will make sure that its ports are being allowed, right?
Okay.
So we know that for a fact the switch B is the leader. It knows which port to allow, which port to allow. So we cannot block this port or this port. And the next guy is switch A. So on the switch A, because the switch B port is connected here, so we have to definitely allow this port. So we need to definitely block this port and this port. Why? Because switch B ports have to be always allowed because it is the root bridge. So we cannot block this port, we cannot block this port, but we need to block this port. So now when the PCA sends the data to switch A, it has to go only via switch B, and it has to go via switch C, and then go to the destination. Is this the right path?
But the path will be too long, right? In this case.
That's why it's your responsibility as a network administrator to select the right priorities.
Okay, yeah.
If you select it like this, your traffic is taking extra hops to go to the destination. So you are not a good network engineer. If you do like this.
Yeah. We should then calculate the total weight, right? The total weight of all the parts and then choose the smallest one. Like,
I mean, you have to, the priority is manually configured, right? So let's say, what is the default priority value? What is the Cisco default value before you configure it? 32678. 32678. 32678. So what happens if the priority matches? Guys, what happens if the priority matches?
Looping.
No, I mean, you connected a brand new box and priority is default 32678. You did not change anything.
I think we can choose any path. No. In that case, also we have to go through switch A, C, and to the destination.
No, there is if the priorities match, if there is no default mechanism, you are bringing down the whole network because there is a loop, right? So that's why Cisco came with a concept called lowest MAC address. So if the priority matches in all switches, whichever switch has the lowest MAC address, that will become the root bridge. So let's say switch A has the, and remember, the MAC address is the vendor given MAC address. So vendors decide the MAC address when they manufacture the switch, right? So so every device has its own unique MAC address. So let's say this MAC address is AA, this is BB, this is CC, and AA is smaller. So this one will become the root bridge. So the formula is bridge ID equal to BP protocol, priority plus MAC address. So even though if all the priorities are same, whichever has the lowest MAC address, so value should be lower, that one will become the root bridge. So in the CCNA exam or in the real time, you need to remember whichever switch has the lowest priority, that will become the root bridge. If all the priorities matches, they don't match in the real time. I'm just giving an example, guys. When you configure a network, you define your own priorities because you want to know which one is your root bridge. But if it's a brand new basic network with no configuration, no manual intervention, in a lab setup, if they all match, the MAC address will win the election. But you as an engineer, when you configure, you select your own priorities. Because you know your network topology, you know which one to select, which one to not, to have the better plan. That is that. Any questions there? Okay, let's talk about let's say quickly. Hari, you cannot talk today. Okay. Shruti, how does the switch elect the root bridge?
By the lowest priority.
Lowest priority of what?
Like the switch.
Okay. So what if all the priorities matches?
So we use the lowest MAC address.
Okay. Can you manually change the priority?
Yeah, we can change the priority manually. I mean, like we can like give the manual priority, but we cannot change the priority, I guess.
I'm sorry, Shruti, you're saying we can or we cannot?
I think we cannot.
Anyone want to contradict that, or do you agree?
We can manually
We can
manually
use
scan
this
it.
bridge ID to change the priority.
No, we can change the priority. That will change the bridge ID. I think it's the other way, Shruti. We cannot change the bridge ID, but if you change the priority, that will change the bridge ID.
Okay, okay.
Okay. Vasanta, are you new to the class, Vasanta? Is this your first class?
Yes, sir.
Oh, okay. Are you following?
Yes, I'm following.
Okay. Can you tell me why do we need a spanning tree?
Like maybe to know the bridge ID.
So you're saying we need a spanning tree to know the bridge ID?
No, like it will prevent the loops. To prevent the loops, we are using spanning tree.
Okay, thank you. Monica, can you tell me if we choose the spanning tree, if we not choose the spanning tree, what we have the problems? What are the problems we can have?
The risk it will be the network will be down by loops.
If we don't use a spanning tree, there will be a broadcast storm and there will
Yes.
be loops in the network, and that will get the network down. Correct.
Yes.
Okay. Now let's talk about the port channel, guys. That will be the last topic for today. Let's say we have one more PC connected here. There is one more PC connected here. I don't have budget to use one more switch. Okay, so this switch is not there. The destination is connected here. So there is only switch A and switch B, and you have the destinations here. Okay, so what if this link go down? What will happen? In the physical layer, if this link go down, what will happen?
The packet will not go forward to the destination.
Yeah,
and we don't have any other backup.
Correct, exactly. So when this PC want to send the data, it comes here. The switch will try to broadcast, but because this link went down, it does not know where to send it. There is no path. The uplink is gone, right? So to avoid that, in that case, what we're going to do is we can put one more link. But what is the problem of putting one more link here, guys? Let's say Lakshmi, what is the problem of having one more link between them? Maybe I'll make it easy for you, Lakshmi. Let me switch A, switch B, destination, switch A, switch B, source or PC. So what is the problem of having one more link between the switch A and switch B?
So it like looping happens here.
Correct. Perfect. So between the switches, the loop happens again. So then what can we do here?
One path should be, one link should be active, and the other one should act like a backup. Like when the first path goes down, the second one should get activated.
Okay. How will you achieve that?
Yeah. By pinging.
Prioritizing them.
Well, you want to prioritize one link over the other, one link over the other?
Yes. If
How do
one
you-
if one link fails, then prioritize them. Then it will be easy to send the data to the destination, right?
But how are you going to do that? How do you set the priority? Do you want to manually set it, like, priority setting on the link?
So we can check right before MAC address, initially we have that MAC address priority. So if there is a priority on one loop which is cancelled, that one has a priority, then we can make it manually. This link, which is optional, another link, we can manually change, right?
No, there is no concept of that. You putting a priority on the link. There is no concept of that. But think about the topic we just learned, the spanning tree. How can you use the spanning tree to block one link and allow one link? If that goes down, the spanning tree will take over. We just discussed avoiding the loops with the spanning tree. So here we have a loop, and we know a concept called spanning tree. How can we incorporate that here? So you both will exchange the BPDUs. Correct? Both switches will exchange the BPDUs. They will elect a root bridge. Let's say there is switch A, this will become the root bridge because of the lower priority. Okay. So this one will allow this port and also this port because both of the root ports, right? So in this case, when the ports are same on the same switch, going to the same switch, the lower port will always be allowed. The higher port will always be in the standby state. Even on the root bridge, if the paths are same to the same switch, when there are two links on the same switch, it will always, let me write that down.
What do you mean by lower port? Assigning the number?
No, port number 1, port number 2. For every
Okay,
port, there is a number that is defined by the vendor. So this will be like first port, second port, third port. It's like a basic number given to the switch. So port number 1, lower port is allowed when there are multiple links on the root bridge going to. So in this case, the lower port will be allowed, the higher port will be blocked. You don't have to manually set the priorities. The spanning tree will automatically do it for you as a protocol itself. Okay. But what if, let's take a step back. What is the disadvantage of that? What is the disadvantage of blocking one port and allowing one port only? Monica, what is the disadvantage of blocking one port and allowing the traffic of one port?
Can you repeat the question again?
What is the disadvantage of blocking one port and allowing the traffic on only one port?
Maybe the data will not be transferred fully.
Let's forget about the data's network service for a second. Let's say there is a highway road. There are two roads to go to the destination. There is road A,
So it becomes one way.
there is road A, and there is road B. So what is the problem or disadvantage of blocking this road and allowing only this road? When this road will go down, then we will bring up this road. What is the problem with that?
I mean, it becomes one way, right? Like,
Okay, yeah, I mean, one the packet goes out and the return traffic comes out. But what is the problem with it?
High traffic.
Traffic.
Exactly. When there is high traffic, we are not making use of our infrastructure very ideally. We are not making full resources use cases here. We are always putting one port in the blocked state and just waiting for this link to go down, and then it will come up. That is not the efficient way of using our resources. We are always making one port down. Let's say there are 100 cars here. Every car has to go one after the other on this link. But if you have two highways, one car can go on this highway, other car can go this highway, like having multiple lanes. So you can go multiple packets at a similar time. So that is called having a logical, that is called having multiple paths to go to the destination. How can we achieve that is called port channeling. So what does port channel really does, right? Let's go one more time here. Let's check on the time. Okay, 10:09. I'll complete that in 2 minutes and then I'll stop there. So we are bundling both of the links into one link. What is doing one link means we are telling the switch that these links are part of one group. So when the packet comes in, from the spanning tree perspective, there is no loop here because from the spanning tree perspective, it's just a single link. But inside of that single link, there are two lanes to go traffic wise. So what does it do is it will bundle them. The switch will bundle them, two ports as one port. You can define, as an administrator, you can define the port number, like for example, port channel 2. And this can be port channel 2 on this side. So this logical interface will have port channel 2 number. This will have port channel 2 number. So instead of port 1 and port 2, we have a port channel 2 number here. So when the packet comes in, when the frame comes in, it will see, okay, the destination is PO2. So it will mark it as PO2. So inside of that, we logically can send on both of the links. From the spanning tree perspective, the loop is avoided because it's only a single link from the spanning tree because it's pointing to the MAC address of the port channel 2. So that's how the port channel can be used to avoid, to make use of both the ports and not having one port blocked. So there are different protocols we can achieve that. The mechanism like LACP, link aggregation control protocol, PAGP, port aggregation control protocol. The time is not sufficient today, guys. We have to stop it here. We have to continue that tomorrow about port channeling, the different types of port channeling, and little bit logic behind bundling. So I'm gonna stop it there, and I'll let you guys ask questions if you have any on these topics. One is trunking. Trunking is like allowing multiple VLANs on the same link by having the encapsulation so that we can separate the traffic. And the second topic is spanning tree. Spanning tree is to avoid the loops between the devices, to avoid the control plane hits. I mean, the broadcast storms and the device when the device go down because of the huge traffic on the loops. To avoid that, we use spanning tree in the loop network. to make that function, BPDU is used. BPDU is a message which is called Bridge Protocol Data Unit. So the switches will exchange the BPDUs and they will elect the root bridge. The root bridge will allow all the ports on it, and it will elect the non-root bridge, which is the second switch. And the third switch will be the alternate switch, which will be blocking the one of the port to avoid the loop. So as an administrator, your responsibility is to carefully define your priorities according to your destinations. Next thing is port channeling, where logically bundling multiple links into one channel to have multiple paths to go to the destination and to effectively use the resources in your network. That's a summary, guys. Any questions?
So all these comes under basic networking concept, right? Or routing concept?
No, this is all data link switching, basic network. I mean, again, some of the points I may be going to the professional level, not at the basic level. So some of the topics may be little advanced. So I'm not putting in barrier to stop it there, right? So I'm trying to give you the real-time knowledge so that it's easy to understand. What if I just say port channel is like bundling the devices, that's it, right? So maybe we are going a little bit upwards, not just the basic level. You know what I'm saying?
Okay, yeah.
But I'll try to reduce that, because I know if I go deep and deep, the time is not getting sufficient. I want to also keep that in mind. Otherwise, it will take 3 months. I want to also keep that in mind and do efficiently the course structure and go accordingly to the plan. We'll see. We'll see. We can adjust, right? We can always adjust. Okay, let me stop the recording there. Give me 1 second.